All right, everybody. Welcome to Genius Call number three, Deciphering Smart Contracts with Montana Wong. Montana Wong is a CPG Genesis member and one of the core developers in our group. He's done all the metadata work on the POP contract, on the BFF contract, on a bunch of your other favorite contracts. He's a brilliant person that we had the pleasure of bringing into CPG last December during our 12 Days of CPG campaign. He was noticed on Twitter for writing this really crazy thread about the Adidas drop and all the ensuing gas war madness. And I think he was just like spotted by Genesis members and said, wow, we really need this brain inside the group. And ever since Montana joined, we've learned so much, and you've helped us answer so many questions about smart contracts and helped us mint from contracts many times and verify the safety of contracts. So Montana, you rock, and super excited to get into it today.
Thanks for the amazing intro, Chris. Yeah, I'm super grateful for having been able to join the CPG community late last year, and since then help build it and build it grow. So, or watch it grow. So yeah, excited to chat more. Just a quick 20-second intro about me. I have a background in engineering. I first really dove into crypto seriously in 2017. I went to Burning Man and I met a bunch of hardcore decentralization maxis there who were talking about building decentralized societies and smart contracts and building a society with no government. And they told me about Ethereum, and they really sold me on vision of the type of things could power. So when I came back from that, I decided I need to work on this. I need to be immersed in this. And so at the time I was working at Amazon as a software engineer, and long story short, I ended up being on the launch team of their first blockchain product over at AWS, which is their cloud business. And we launched a service called Amazon Managed Blockchain in 2018. And pretty much it's a Infura Alchemy competitor. It's pretty much like blockchain infrastructure for developers. And after that, I left Amazon, started my own company, and since then just been working with creators and brands mostly. And earlier last year, I started a company with my co-founder, I think he's in this call, Spryz, and we're a product studio and Web3 agency, and we've been partnering with creators and brands to help launch Web3 projects. We most recently worked with BFF on their launch, and so just right now full-time working in Web3, and just love watching how this whole space is growing. I really started building in the last bear market. And so just seeing how things have shifted so much since then has been awesome. And I'm just really excited for the next decade, really. I feel like the crypto space is at a really good point where we have the right level of mainstream adoption, but we're still all early enough to really find where all of our roles within the ecosystem. Cool. So should I just continue? Chris, are you there?
Let's keep going. Yeah.
Okay,
let's roll.
Cool. Okay, so I'll just keep going. Okay. Yeah. So let's get started. So the key outcomes that I want all of you to sort of get out of this, and this, I knew that there was going to be a lot of people who aren't developers on this call, and that's good. And so I wanted to cater this to a general audience of people who are somewhat familiar with Web3, have MetaMask wallet, have maybe minted NFTs before. And so the key outcomes I want of this call is to, one, learn the basics of how smart contracts work, transactions work, how to read and verify a contract before interacting with it. And you're not going to leave with this with being able to decipher the Uniswap contract or anything, but just being able to really identify the key parts of a contract and getting a gist of sort of what it's doing, and being able to learn how to know how to deep dive more if you want to on a certain contract. And then finally, we'll end it with identifying common red flags in malicious contracts. This will really help you just understand how most of these scams work and how to prevent yourself from getting hit by them. So the call is going to be broken up into these main parts. I'll try to stick to the timelines. I don't know how good they'll be, but we'll start with just some basics about the smart contracts. I'll walk through a couple of contracts. We have a little hands-on demo midway through, and then we're going to end it with looking at the red flags and Q&A if there's time. So 101 smart contract transactions. So smart contract transactions are transactions that trigger code that are stored on the blockchain. And when this code is called, it actually runs something, right? It could be running like an NFT mint, or it could run a coin swap. And these transactions, they either fully pass or fully fail. There's no sort of, it's not like in Web2 where like, something can execute halfway and then fail. Like with the way that blockchains are designed, like a transaction either fully passes or fully fails. So if you're trying to mint 2 NFTs, let's say that there's only one remaining left to mint, but you try to mint 2. Well, it's not the case where you would just mint 1 and the other one would fail. Your whole transaction would fail because it needs to either fully succeed or fully fail. The best Web2 analogy, I think, of how to think about smart contracts transactions are HTTP requests. And that's a bit technical. But people, developers who have a Web2 background might really understand that analogy. And I have a really basic diagram that I found online on some Medium article that really helps sort of paint a picture of like the analogies between Web2 and Web3 when it comes to like the tech layers and where smart contracts sort of fit into like a Web2 model. And so essentially, if you take a look at this diagram, and I don't know if you can see my mouse, but when it comes to a traditional Web3 application that you're interacting with, the way sort of like the layers start with the user and their wallet, which is attached to the browser, and they interact with the front end, like a website usually, or a mobile app. And that front end is able to connect with smart contracts through node providers, which are nodes that are running the blockchain. And most of them are managed now through services like Fira and Alchemy. And so the user is able to perform transactions through the wallet that use a node provider to actually talk to a smart contract. So when you actually submit a transaction to the network, your MetaMask prepares the transaction, you hit accept, it gets sent in from the front end through the node provider to the smart contract where it's actually run. And obviously the smart contracts live on the blockchain. And so as you're thinking about, if you're a builder, creative, or you're more on the community management and marketing side, like looking here at the stacks, this will help you understand sort of like what layers of the stack you really need to familiarize with as you find your role in Web3. Like if you're a product designer, you'll spend a lot of your time thinking about the wallet and front end experience. If you're a developer, you'll probably spend a lot of time, depending on if you're a back end or front end dev, focusing on the smart contract layer. If you're an artist, you probably will think mostly about the blockchain layer because, I think when it comes to creating art, I think we're finding that like the choice of blockchain really is part of the messaging nowadays with like what blockchain artists decide to go with. And if you're a core dev, you're probably only working on the blockchain side, improving the blockchain. We know that the next evolution of Ethereum's coming out soon, so the core devs are working on improving the core blockchain code. So yeah, that's just a quick overview of what a smart contract transaction is. Just think about it as a special type of Ethereum transaction that triggers code that's stored in the blockchain. And so let's look at a really basic structure. Let's structure a really, really basic smart contract. This is a contract that just stores a number called count, and that number can either go up or down based on people interacting with the contract. And so this is written in a language called Solidity, which is the most popular programming language for Ethereum. There are multiple, but Solidity is just the most used. And so in the very top, usually there's like a code license. A significant part of the code that you'll see sort of deployed, especially for NFT mints, are MIT license, which means open source, do whatever you want with it. You can't sue the author if you use their code and build something else with it. That hurts people. Under that, you see the version of Solidity. So think about every programming languages have versions, just like apps. They get upgraded over time. For example, like the NFT ERC 721 standard wasn't around when the first version of Solidity was out. So over time, the language evolves to support more use cases. And so you always have the contract name next to the word contract, and that helps you just identify like what the contract is doing or who it belongs to usually. And so usually underneath the contract line, this is where all the contract storage variables are declared. And those are just places where information will be stored on the contract or on the blockchain through the contract. And so in this case, we only have one variable. It's called count. And you'll see the word uint. That means unsigned integer, which just means a positive number, a positive whole number. And so it just means that, the number count will be, from 0 to, a very large number, potentially. So under that, we have our functions. Our first section is read functions. And these are functions these are pieces of code that allow you to read sort of information on the blockchain. It doesn't require a gas transaction to do because you're not modifying blockchain state. And so when you don't need to modify the state of the blockchain, there is no gas required to do that. You can just sort of do it for free. And so this function get, all it does is return the current value of count. And underneath that, we have write functions, these are functions that when you execute the transaction to the smart contract, it actually updates the state of the blockchain and will require gas to do that. And so the way that whenever you do a transaction and you spend gas, that's because each line of code that you have to run each line of code in that function that you're calling, that consumes a certain amount of gas. And so the amount of gas that you spend is a factor of how much code you're running with your transaction and also like what you set your gas price to be. So in this case, there's only two functions. There's increment, which increases that number by 1, and then decrement, which decreases the number by 1. And so if I call get at any point, it'll be whatever value of count is at that certain time. So this is a really, really basic contract, just to get you the idea of sort of the components of one. Let's look at something a little more complicated that might also be more familiar. So here I have the Doodles contract. And so there's a lot more information here. I'll walk through it really slowly. But essentially, it's an NFT contract. And this is a contract that manages sort of the Doodle NFTs, and also you can mint, it was used to mint the NFTs from as well. And just a quick disclaimer, the technology, the optimizations that happen in this space happen really fast. Like when you look at the Doodles contract now, and it came out probably, let's say like 6 months ago or so. I think now developers would consider this to be a pretty unoptimized, naive contract. A lot of optimizations have happened since then, including the Azuki standard. But that being said, it's a really straightforward, simple, and clean contract. So I thought it was a really good example to use. So you can see on the top, it's using an slightly older version of Solidity. There's this thing called, the other contract didn't have it, but there's these import statements. And you can think about imports as importing other smart contracts that you can reuse in your code. It's a simple way of allowing developers to reuse code that's already written, so you don't have to reinvent the wheel. And it's importing a couple of contracts that are from the Open Zeppelin group, which is it's an open source. It's an open set of open source contracts that have been audited heavily, and most major projects use from them. So if you see people are importing contracts to Open Zeppelin, just know that those are super safe. Those have been super audited. And so a slight difference in this contract is you'll see this thing here. So next to contract doodles, there's this is ERC 721, ERC 721 enumerable and ownable. This is called inheritance. It's a programming concept. I won't get too into it, but essentially allows the contract that we write to inherit sort of all the functions, all the storage variables of those other contracts. And so so this Doodles contract is inheriting like the ERC 721 contract, and that contract is a standard of NFTs. And so that contains sort of all the internal storage and functions that are required to power like an ERC-721 NFT token on the blockchain. And so when you see an NFT contract, it will always say, it'll always inherit from ERC-721 or something like ERC-721A, which is a sort of a improved version of ERC-721. And these two other ones are not as important to know right now, but they're just enhancements to make writing the contract a little easier. And so going through these storage variables, most of them will be very straightforward. Provenance is string in programming is just a collection of numbers and letters, and so you can use it to store like names, addresses, etc. Provenance is just it's just a way to verify that the metadata is not tampered with. Sale is active, so Boolean is just a true or false value, and so it can either be true or false. So it's really good to use for logic statements. And so you can see that Doodle's team had a field called storage variable called sale is active, and so it's used to like turn on the mint or to have it so you can't mint until that variable is changed to true. Base URI is related to metadata. They have another Boolean variable around activating the allow list, and then you can see some number values. There's max supply, which is set to 10,000. Max per public mint, that's how many you can mint per transaction in the public mint, and then they have the price per token defined here. And so these are things you can go. Usually they're posted in the Discords or on the websites, but you can actually go to the contract directly and look at these and verify for yourself, what these values are. And then they have this field called allow list, which is storing something called a mapping. A mapping, you can think about it as a dictionary. And in this dictionary, instead of words and definitions, you have Ethereum addresses that point to how many they're allowed to mint on the allow list. So the way they built it is like, if you look at their address, you can get back the number of how many they're allowed to mint. So in this case, I think everyone was allowed to mint 2. I can't really remember. And so let's go through their mint allow list function. It's not that long. It's like 5 lines. And you'll find that most mint functions that happen on Ethereum, they're mostly just like logic checks to make sure that you're allowed to mint. And then the actual mint code, which is usually pretty small. So in this case, let's kind of just walk through this slowly. So you can see that this function is called mint allow list. You can pass in. So here there's a variable called number of tokens, and so when you see these parentheses after the name of the function, those are inputs that you provide into the function, and that those inputs are changeable. So like for example, like number of tokens is something that you pass into the function. Usually their front end would handle this for you, but if you're minting from contract, which we'll do later, you can actually modify this yourself. So you're passing in the number of tokens variable. Let's say it's 2, and then external means that the function is meant to be called by by a user outside of the contract. So and then payable means that you can send ETH to the contract through this function. And so most mint functions, unless it's a free mint, will have a payable field. And so quickly going through the conditions here. So this line, the first line of the function says uint ts equals total supply. Total supply is another function that's defined elsewhere in the contract. And so within a contract, a function can call another function. And so total supply just returns like how many have been minted so far. And so this function is just grabbing that number, and then it's doing a series of checks. So the first check is when you see a require statement, that just means, hey, if this following condition isn't true, then fail the transaction. So a lot of times when you're minting, let's say you're minting and it's about to sell out, your transaction will fail, and it's usually failing because of one of the required statements in the mint function. And so in this case, the first condition says is allow list active. And so remember, that's a Boolean. So if it's true, then it is active, then the code will continue to the next step. If it's false, then the code will fail at that point and your transaction will fail. So the next line says require that the number of tokens is less than or equal to, and then it's calling allow list message.sender, which just is looking up it's using message.sender, which is which equals like it's how you look up a user's Ethereum address, whoever's calling the function. So it's checking in that dictionary and saying how many items on the allow list, so how many can they mint on the allow list. And so this require function checking is the number of tokens less than or equal to 2. And so if the number is 2, if number of tokens is 2, then it'll pass on to the next line of the code. Otherwise, it'll fail there. The next line says TS plus number of tokens is less than or equal to max supply. And so remember that they set TS to what the total supply is. Right now, let's say that only 2 have been minted. And so 2 plus 2 is less than or equal to 10,000. So it would continue. But let's say that 9,999 have been minted. Well, 2 plus 9,999 is 10,001. So that would obviously be greater than max supply. So that would fail there. And finally, the last check is just making sure that you've sent enough money to the contract as part of your transaction call. And so in this case, like within Solidity, Ethereum transactions referenced to as a message. It's kind of confusing, but message.value, that equals like how much Ethereum is sent as part of the transaction. And so not all transactions on Ethereum need to contain, they don't all need to send ETH. But in this case, this one does. And so if you're not sending enough ETH, then it'll fail the transaction. If you send the right amount of ETH, or if you send more ETH, they'll accept it. So you can definitely send more ETH than you need to. They would happily take that. And the final part of the function is really straightforward. There's this little bit of line of code here that's referencing the allow list. It's just updating the allow list to subtract how many tokens you've purchased. And so that way you can't mint again because it'll show that you've already minted your allow list. And then this last 3 lines here with the for, that's something called a for loop in programming. That's just a way of allowing a certain lines of code to be run over and over again until a condition has failed or is no longer met. So in this case, it's saying, as long as, just to simplify it, like we have the number of tokens is equal to 2. So we're going to run this piece of code twice. And this piece of code inside the for loop is safe mint. And that's an ERC 721 function that just updates, that actually mints the token to someone's address. And so I know that's a lot, but hopefully that sort of gets you into an understanding of like how to go and walk through a mint function like that. I know like there's a lot of programming concepts that probably, if you're not a developer, they don't make sense yet. But with looking at smart contract codes, you can always Google like, what does this do? What does for loop? What does that mean? You can always go as deep as you want, but at least this should give you like a surface level idea of how most of these mint functions work. And so
yeah, that's super helpful. It's like some of the stuff it just seems like it's like so straightforward when you actually understand what it's doing, requiring just making sure, your wallet is on the list, but then it's just sort of like abstracted by these like, the code, the formatting of the code and like the parentheses and the underscores and the kind of like just those little code words once you start understanding what like the require means and uint and like all that, what it means when it's importing from Open Zeppelin, like that is so helpful. Thank you.
Sure. So I'm going to kind of fast forward through this slide, but essentially so they had a public mint function, which is just called mint. It has like a bunch less required checks. It doesn't check like that you're an allow list. It just like lets you mint essentially. But I really wanted to point out this one thing. So when you look through most contracts, like most of these mint functions, they'll call safe mint or they'll call a function that's defined somewhere else. And that's really just to keep the code clean. Like you don't want to have a function that has like 50 or 100 lines of code. It's hard to read and hard to maintain. And so what safe mint actually, when this sort of mint function is calling safe mint in this for loop, it's actually calling a lines of code that are defined somewhere else. And it's calling underscore safe mint, which is actually part of the ERC 721 library by Open Zeppelin. And then this is actually calling another function, which is called underscore mint. And this is actually where the meat like the true logic of like minting happens. And so when you think about minting an NFT, the best way to think about it is like when you have an NFT contract, it itself has, let's thinking about it in like a really simple way, like the NFT contract is a smart contract that has like some storage, right? That it uses to maintain some state on the blockchain. And so it has like, you can think about it has like an Excel file, right? Where all the owners of the who hold a token are written on that sort of file. And then whenever you mint one, it adds that person's address to that file and says, oh, this person now has a token. And this is the token ID they hold. And when you buy and sell it, it also updates. Or when you transfer it, it says, okay, this person no longer has one. This new person has one. So when you're actually minting one, you're actually just updating this internal ledger of who holds what, how many tokens and which tokens they hold. And so this mint function here is actually doing that with these lines of code right here. It's updating like how many someone's holding, and it's updating like this owner's dictionary of like who's holding what token. And so actually what it's doing is actually quite simple. And you'll find that like most of these most of the tokens that are sort of built on Ethereum are the underlying technology or the underlying logic is actually really simple and straightforward. But it's like wrapped in all these other constructs that are like very complicated. So why don't we, do something a little more hands-on and actually mint. So I actually have something prepared. I'll drop this link in the chat. But essentially, like I put together and launched like a really basic NFT contract to do like a quick walkthrough of how to actually mint from a contract on Etherscan and how to get a sense of like what Etherscan is showing you and how that relates to like what's on the contract. So I'm going to drop a link in the chat. Feel free to follow along if you want. You don't have to. It's a free mint, so nobody gets any money from this. And Stuart, who is the artist behind the Pop collection, graciously offered a piece of art for this as well. So you can have a nice little collectible if you mint it. So if you're following along, that link will take you directly to this write contract tab. And so I'm going to quickly just, and if you can't see, if I need to increase the text size, let me know. But essentially so Etherscan, I think most of you will probably be familiar with what this is, but essentially it's a block explorer, allows you to kind of see the balances of certain addresses on Ethereum, lets you see transactions that are pending that you've done, how much money someone has. It also lets you look at smart contracts and the transactions that have happened on the smart contract, and depending on who created the contract, they can actually upload the code so it's readable on Etherscan. So that's optional. Like some developers don't upload the code, but most developers will do it just as a form of gaining trust with the community. And so here you can see that there's a really simple NFT contract. This one is an ERC 721A, which is the Izuki standards. So it's a more optimized version of ERC 721 Open Zeppelin contract. And here we have a mint function. And so this is a mint function where we can actually go and mint. There's a check to make sure that you hold a pop. So you can only mint it if you're holding a pop in that wallet. And so one thing about minting from Etherscan is when you have a contract, and you have like read and write functions, you can actually go and see what those are here in a simplified view on this tab. So if you hit contract and you go to read contract, you can see all the read functions. And so I can actually go and, like I mentioned, like these read functions don't cost any gas. And so if I hit total supply, it'll say 3. I minted 3 to test earlier. So there's 3. You can see how many the max mints per wallet, which is 1. And then the functions that have that you can pass information to, you can actually pass information. So I'll pass in this address. It'll say 0. I haven't minted anything to this wallet yet. And similarly on the write contract side. So let me actually disconnect because just to show you guys how to do this. Okay. Oh, wait. Okay. So to actually mint from contract on Etherscan, you'll go to the Write Contract tab. You'll hit Connect to Web3. It'll ask you to connect Etherscan. You hit Accept, and then you have to hit it again for some reason. And then once you're connected, it'll have a green dot here. Like I mentioned, like the functions that are on the contract directly are visible here. So if I can go and look at the mint function here, I can read through the code, make sure it's doing what I think it's supposed to do. I can go over to write, I can hit mint, and since it's a payable function, it'll always ask you how much ether you want to send. You can just hit 0. If there's there's no other inputs on this one, but a lot of other mint functions will have like how many do you want to mint, things like that. So in this case, I'm just going to put 0. I'll hit write. I don't think I have enough gas actually. So what I'll do is I'm going to. Well, actually, no. This wallet doesn't have a pop, so it won't succeed. But anyone who's yeah, it looks like some people have already minted. Cool. So yeah, you can see that
I just minted for like $10. That was cool.
Yeah, it's like super cheap. So you can see that like people are minting it. And so if you essentially you would execute the transaction, it would finish here, and then you could go and track it, and you can go and check on OpenSea, and you'll have it in your wallet. But essentially, this is exactly what you're doing when you're using a mint site. You're doing the same thing, like the front end is creating like a transaction to talk to a certain function on a smart contract stored somewhere, and then it's going to prompt MetaMask to get you to approve it. And so this is just like a really technical way of doing that. Like, obviously having a website and a mint button is more user friendly, but end of the day, you can go as like a more savvy user and just go directly to the contract and call the functions on it directly. And so, so you could see here, let's just pick on this person. And so you can see that you can see that here in Etherscan, you can see the method that they called. And so earlier I toggled the minting. So I set that field to be true. I did some admin minting to test it out. And then this is just like a contract deployment. So it's like a jumbled mess. But you can actually go and track and see what people are calling on a contract. In case like, you're curious about interacting with the contract, you can see what other people have done, and you can actually look into the transaction, and you can just see what actually happened. So, this person called others.eth, they called mint. This is how much gas they spent. So they spent $10 on gas, and they transferred a ERC-2721 tokens to their wallet. So null address so when you mint an NFT, like it always says it's sent from null address. Yeah, that's pretty much how you mint from a contract. And we'll show you a little bit. So I'll show you a little bit more about like how you can incorporate this into your Web3 flows. Because it's not always easy to know like where is the contract, what's the address of the contract that on this website, what function am I calling? So I'll go through sort of like an example of how to actually go from like mint website to like line of code that you should be looking at next in this demo. So I actually have I have an example here. This is like a example degen free mint. Those are really popular right now. It's kind of hard to find because most of these have minted out. So this is one that hasn't minted out. And so if I'm, just trying to get a free mint, and I don't want to get wrecked, one thing I can do is when I go to the site, when I hit mint, so when I hit mint, MetaMask actually shows you a couple of pieces of information that's actually really, really important for you to actually look at and sort of DYO or do your own research on before you actually hit the confirm button. Because once you hit confirm, it's unlikely that you can, there's no going back unless you're able to cancel it really fast. So what you see here is you're seeing my wallet interacting with this contract at some address, and it's calling the mint function here. So MetaMask is going to show you what function on the contract am I about to interact with, and what is the address of that function. And so I can actually click here on the address and hit view on Block Explorer. And I do this for every contract I interact with, other than like very established platforms like Uniswap or OpenSea. Is it opening? Oh, okay, it opened a bunch of times. So now you can see that I'm on Etherscan, and I'm looking at the contract that I'm about to interact with. And so it's called DGenOrgs. Cool. It checks out with what's on the site. I can see who created the contract. I can check, see I can look at the developer's address, see if they have like any transactions in Tornado. There's obviously like red flags you can always look for. And to actually go and see what line of code I'm actually going to interact with, I'll hit contract, I'll look at the code, and I'm going to search for their where they actually define the code. So here it is. You search up DGenOrgs, you can see that it's an ERC 721. So it's not an ERC 721A, so it's not going to be gas optimized. And so here I actually want to go and look at the mint function, because that's what I'm going to call. So I'll go scroll until I find it. So here, function mint. So I can actually go and look through the function. It looks pretty straightforward. There's a couple of require statements that make sense. There's a condition to know whether or not the mint's free, and then there's a for loop with safe mint. So I know that, okay, this mint function looks safe. Like whether or not the project is a rug, I don't know, but at least like I know I won't get my NFT stolen by minting it. I know it'll be free. So this is what I always do, and I recommend people do before they mint something that's free or like from a shadowy group. You just want to go and double check, kind of just eyeball the code, make sure there's nothing weird there, and check out the contract, check out developer's address and all those things. And I always check and make sure that there's other transactions happening to it. So you can see that other people are calling mint. There's people who are pending calling mint right now as we speak. And you can see, and you can actually clicking these transactions, see that people are minting. You can see that, there's token IDs being sent to their wallet. So, okay, like this seems to be doing what we think it is. And then after you verify something, you can always, go back in and finish the mint. And so this kind of brings us into the final phase of this call is common red flags. And so when it comes to sort of browsing Web3, there's a lot of easy ways to slip up or do something where you don't expect it. You're tricked into doing something that you don't expect, and it can cause a bunch of financial harm to you. You can lose your tokens, you can lose your NFTs. You can straight up, get your wallet hacked by losing your seed phrase or revealing your seed phrase. So my goal here is just to kind of go over the most common ones right now, and just kind of give you a very sort of high level sense of like how to avoid these and how to spot them. So I think like before even going through all these red flags, like the best thing you can do is just have a dedicated wallet or an address, an account in MetaMask that's used to do everything to do anything that's new. So like minting an NFT, connecting to a new website, doing claiming an airdrop, etc. That's the easiest way, because most of these scams target you by getting you to connect your wallet and do a transaction on your main wallet that contains, money or valuable items. And then from there, they just can drain you. And so if your primary wallet for exploration is something that holds very little value, then you can avoid sort of almost all of these issues. That being said, let's go through all these just so like you have a game plan and a framework for browsing. So the first thing that I always check before interacting with something, especially like that's prompting me to do a transaction, is actually verifying, is the contract actually even verified on Etherscan? So like I mentioned earlier, like many developers, especially in the NFT space, will verify the code so you can actually read it on Etherscan. But by default, when you upload code to the blockchain, it is not it's not readable. So when you actually write Solidity code, when you write smart contracts in Solidity as a developer, before you actually upload it to the blockchain, you run it through a program called a compiler, which converts it into code that machines can read. So Solidity is code that humans can read, but machines can't read Solidity. So developers feed Solidity into a program that outputs something called bytecode, which is what machines can read. And this is what it looks like. So this is actually what gets uploaded onto the blockchain. It's a bunch of numbers and letters, which we don't know what that does, right? And so here's a contract that the developers uploaded. They didn't verify it. So as a normal user, I have no idea what's going on. So if I call the mint function on this, it might actually mint me an empty, it might not. I don't know, right? So like if I go and see a contract that doesn't verify, most likely I'm not going to interact with it unless it's like a solid team and they have like a valid reason why they don't. Like let's say it's a new startup and they raise a bunch of money and they want to protect their IP. There's some that do that. And so unless it's like most of the time, I just straight up will walk away if I see this. And so here's a project only here that did that. And so that's step one. Check and see if the contract's verified. And you just click the contract. If you see machine code, you just stop. So secondly, when you actually go and are trying to mint something, you want to actually check the contract address in multiple places. So let's go back to DGen.orgs. So if I want to mint, I want to make sure this is the right DGen.orgs site. Like it's not like DGen.orgs.io or .xyz. Like it's very easy to get tricked into going to a fake mint link. So what I would do is I'm going to go and take the contract address and actually search in multiple places. I'll search on OpenSea and make sure, hey, is this like the right contract? And so you can type the contract address directly in OpenSea, and it'll show up the collection. And you're like, okay, like this is, this will show up as like the valid collection on OpenSea. It might be verified. But here I can check, okay, this is the right one. It has, the right number of owners, the items. You can check it. Usually they post the smart contract link on Discord or on Twitter, so you can always verify against there. But yeah, you always check the contract link and the contract address in multiple places just to verify, okay, this is the right one. And so number three, when a transactions prompt is asking you to set approval for all. So this is the exploit that gets people to lose their $1 million apes, $1 million punks, etc. It's very hard to spot. It's very easy to fall prey to because it's just it's very difficult to understand unless you seek out to understand this concept. But essentially, the way that ERC-720, the way that Ethereum tokens are designed, whether it's ERC-20 or ERC-721 NFTs, is they're designed in a way that allows you to grant permission to another address, and the address could be someone's wallet or a smart contract. Allows you to grant that other person's address permission to control your NFTs. And the reason why that's built into technology is to allow things like marketplaces to exist. And so, for example, when you might know this, or you might recognize this from from selling on OpenSea. But whenever you sell an NFT on OpenSea, before you actually list it, it'll say set set approval to OpenSea to sell the collection for you. And so when you actually do that transaction, that's what it's doing. It's granting this approval to OpenSea to actually manage your NFT. And so the way that works is, so you grant OpenSea approval to manage your NFT, and so that way when later on when you're like doing your own business or you're enjoying your life, like if someone wants to buy your NFT, when they perform the transaction to buy your NFT, OpenSea can fulfill that order by taking the NFT out of your wallet and putting it into the wallet of the buyer. And so in order to actually have that happen, where you don't even need to be present, you can be on a beach somewhere and that NFT leaves your wallet, like you have to grant OpenSea sort of authority over that NFT. And so, in this case, we can trust OpenSea more or less, like their contracts are audited, battle tested, haven't been hacked at a big scale yet, as far as I know. So most people are okay with granting that approval, but you can grant that approval to anyone. And so these hackers that exploit, that steal apes from people, they actually exploit this feature of NFTs. And so let's just go through an example of like what that really means. So I have these, fake NFTs that I've made on the test net. So there's like a test blockchain that developers use to test on before they actually deploy stuff to the mainnet. And since you don't want to spend gas testing on mainnet, they created a test network where you can use free money to test stuff. So I have this NFT called Fake Pop, and I hold 4 of them. And what I'm going to show you is how I can be tricked into signing. Like I can be tricked into thinking I'm minting something, but I'm actually approving a hacker to actually take control of my NFTs. And it's very hard to spot this, but if you know how to, then it almost becomes like second nature to always check for this when you're minting. So yeah, on this test version of OpenSea, I have this thing called Fake Pop. I own token number 1. It's owned by me. And so right now, so there's a tool called Revoke Cash. I'm gonna teach you guys how to use this, but essentially this tool allows you to see who you've granted this approval to. So in this case, you can see that I have 4 fake pops and I have not granted anyone access or anyone the ability to actually, manage it for me. But if I go and ran this on my mainnet wallet, you would see I like granted a bunch of approvals to OpenSea, and you should definitely check and see who you've granted approval to on your own hot wallet later, and remove it for any that you don't recognize. Okay, so I have this NFT called Fake Pop, token ID 1. So let's say that let me actually pull up. Yeah, here it is. So here's the contract for Fake Pop on Etherscan. And so whenever you connect your wallet to a website, specifically a scammer's website, what they're doing is once you click connect wallet, they get your wallet address. At that point, they can't do anything. But what they can do is they have an algorithm that they use, that they take your contract, they take your wallet address, and they calculate what the most expensive thing in your wallet is, whether it's an ape, a moonbird, a pop, etc. And then from that point on, their goal is to get you to lose that item. And so what they'll do is, you think you're minting, ape airdrop or whatever, whatever it is, and you have like a certain amount of time to mint it. Like it's minting out, you have to mint it now, and so it drives a lot of FOMO. And so people usually just click, and they approve, and they don't understand what they're doing. But what they actually do is they find out what the most expensive thing in your wallet is, and then they create a transaction for you that actually gets you to approve them to manage it. So what they actually end up doing is they get you to approve send a set approval for all. And so here, I'm going to plug in a couple of values here to shoot. So here, oops. So here you can see that I put for operator. So that's the address that's able to manage the NFTs for you. Like I'm putting in like the scammer's wallet, and then I'm setting approve to true. So think about it like this. I'm like ready to mint, this thing, like, let's say the Discord got hacked, the hackers put like a fake link. I'm here, like, I want to hit mint. So I hit mint. And instead of like it actually pulling up a mint function, a mint transaction, it'll actually, it'll pull up something like this, where it's actually trying to get me to set approval for all, right? And so you always want to check before you hit mint, like, is it saying set approval for all? Because right now, I think as a user, like, who has a bunch of FOMO, like, I think I'm about to mint this NFT secret airdrop from Bored Ape, so like I'm probably not gonna look at any of this, but as a smart Web3 user, you're like, okay, what am I actually doing? So it's saying set approval for all, and the address here, it says scammer's wallet because I have it stored on my MetaMask, but it would say like an address, and that address would be the scammer's wallet. So you want to say, okay, if you see set approval for all, you instantly stop and say, okay, it's trying to get me to grant control of my NFTs to someone else. Like, I'm going to reject here. But just for the sake of the demo, let's hit a confirm. So what I just did, just to recap. So I thought I was minting something. The scammers, they identified the most expensive thing in my wallet, which was a fake pop. And so they created a transaction for me to approve, which gives this address access to control them. And so let's just see if it's completed. So it's completed. So at this point in time, I still have this NFT in my wallet. It's still here, it's still owned by you. But now the scammers can actually move it out. So what I'll do is I'm going to sign into a different wallet. It's called Scammer's Wallet. I'm going to reconnect to this. So this is exactly what they do, except they have like scripts to do it much faster, so they can steal it before you even realize it's gone. So I'm doing this manually just to kind of show you what's going on. So sometimes Etherscan does this where it takes a second to, one sec. On Etherscan usually works great, but on the test network, it's always like super slow. I have to refresh a few times. Let's try a different browser or different tab. Here we go. Oops. Yeah, I'm going to connect the scammer's wallet to Etherscan. And so now, as a scammer who has control over this poor soul's NFT, I can actually call this function called safe transfer from. This is the function that actually is used to move NFTs from different wallets. And so when you're transferring your NFT to your other wallet, to your ledger, like you're actually calling this function on the contract. When OpenSea is helping you sell or buy NFTs, it's calling safe transfer from to move the NFT from your wallet to the buyer's wallet. But at me as a hacker who's now been granted access to yours. So let me actually just show you this real quick. So if I look at this now, you'll see that and on the revoke, it says I have given unlimited allowance to this address now, which means that this address is able to freely manage all of my pop NFTs, which is bad. Like, if you see something like this, hit revoke like immediately, but I won't for the sake of this example. So now I'm going to go and actually transfer the NFT from the unknowing user's address to my address, and then token D was 1. Let me grab that address real quick. So here you can see that I'm literally saying, take that NFT, give it to me. I'm gonna hit submit. So you can, yep, bam, confirm. And then let's view it. And I can go, now the scammer can actually go and do this for all the NFTs in that wallet. So there was 4, I can do it for all 4. But in this case, I'm just showing it for 1. And this is what they do. So once you granted approvals, like usually like a few minutes later, you'll start to see everything slowly drain out of the wallet, and you won't even know. So like done. So like you see that, bam, NFT was transferred from good guy wallet to bad guy wallet. Here on OpenSea, you can see now it's owned by you. So let me actually sign back into the good guy. So as the good guy, this is what you'll see. It's owned by the bad guy, and it used to be owned by me. 40 seconds ago, it was taken out. And so
you made the username bad guy. I love it.
Yeah. But yeah, I mean, I like the good guy has no idea that it happened. Like you thought you minted like other side land or whatever, and you ended up not getting anything, and your NFTs are getting stolen, and you're freaking out. You don't know how to stop it, and because like at this point they have free control. And yeah, the best thing you can do at this point is just hit, revoke the permission, so that way like they can no longer go and take anything out. But usually once they have permission, they have scripts to just take it out as fast as possible. So once you get to that point, you're a bit too late. But yeah, that is how. Yep, that is how most of these scams work. You think you're hitting mint, you're actually calling set approval for all, and then after that it's over. So you can see how like if you're using like a burner wallet, if you hit set approval for all, it's not going to do anything because you don't have those NFTs in your wallet to actually get approval for, right? So that's why you always want to use a burner wallet for these like degen things. But yeah, that's it. So I guess
that was brilliant. I can't believe you went through so much setting up all the different accounts and contracts to actually show how somebody would be compromised on the back end, not just like say, because you could have just said, hey, if you see set approval, just don't do that. But we got to actually see how a scammer would actually do that and then interact with the contract to drain your wallet. And then we got to see on Revoke Cash how we could get those perms out to keep people safe. So that was very cool, Montana. Thank you. And everyone in the chat is super excited about the free mint. And I don't know what's going to come from that, but maybe there's something cool down the line. Who knows? You're awesome. I'm gonna thank you so much for Genius Call number 3, Deciphering Smart Contracts. Let's all kind of like spread the word on Twitter about all the fun we're having and all the things we learned. I'm going to wrap this recording here, and then we'll jump right back into voice chat for Q&A.
Sounds great.
Thanks, Montana.